A shop owner determines that on average his shop performs an oil change in 28 minutes with a standard deviation of 4.7 minutes. The z-score of a car in the shop is negative 0.8. How long did the oil change take for that car? So for this problem, I started again by doing a little sketch. So I have my bell curve. It's not drawn super well to scale, but it'll work. So in the center of the bell curve, we have 28 because that's the average number of minutes that it takes for him to do an oil change. Then over here, we're trying to find x, which I put it on the negative side because I know that the z-score is negative 0.8, which means that it is a little bit less than one standard deviation below the average. And then I put on here, just for reference, 23.3, which is one standard deviation below average. So I know that my x is going to be a little bit more than 23.3 minutes. So I'll just use that for reference to make sure that my answer is actually plausible. So the first thing I know, the z-score of x is negative 0.8. So all I'm going to do is plug that into the equation to find the z-score, which means I have negative 0.8 equals x, right? Because that's the variable we're trying to find, x minus the average, 28, divided by 4.7, which is the standard deviation. Now all I have to do is solve for x. So the first thing I'm going to do is multiply both sides of the equation by 4.7 to get rid of this 4.7 here. So I got rid of that, and then I need to do negative 0.8 times 4.7, which equals negative 3.76. So now I have negative 3.76 equals x minus 28. Next step, all I have to do is add 28 to both sides of the equation, so I can get rid of that. And then I have negative 3.76 plus 28 equals 24.24 equals x. So I know that the oil change took 24.24 minutes. And I know that that's a plausible answer because when I look back up at my bell curve, I know that we're a little less than one standard deviation below the average, and one standard deviation was 23.3, so I knew it was going to take a little bit longer than 23.3 minutes, and that seems just about right.